Good morning. I thought I'd work out a problem using the method of sections. So remember, in the method of sections, we're literally going to take our structure apart and do two sections by making a cut. And the cut we're going to make is through the members of interest. So I've got our members of interest listed down here, EF, CF, and BC. Let me go ahead and make that cut right now. So through EF, through CF, and through BC. Okay. Let me pause while I draw the cut portion. All right, so I've got the section that we're working with, the free body diagram, almost finished. I'm just labeling EF, CF, and B or CB. Those are the three members that we're talking about. I want you to notice a couple things. So I'm using the section that does not include the supports. So I will not be solving for the reactions at A and B. They would not come into play because the section that I'm using doesn't include those. If you chose to use the bottom section, then you would definitely need to know the reactions at A and B. But for the section that I'm using, really not that important because they're not in the free body diagram, of course. All right, so let's see what we've got going on here. So we need CF and CB. If I take a summation in the X direction right now, I think we only have one unknown. So let's see what happens with that. Let me get a different color though. I don't really like that brown too much. All right, so summation of the forces in the X direction. So we've got 4 kilonewton force. That's the external force being applied at point E. Minus CF is equal to 0. That means that CF is equal to 4 kilonewtons. And it came out to be a positive number, which is not to indicate that the force is positive, but that I took a good guess on the direction. So I have that pulling away. So CF is 4 kilonewtons, pulling away from the pin in reaction to the tension of the member. So member CF is in tension. That's nice. Let me go ahead and put that in here. That was a quick one today. All right, I need to take if we take, for example, I either need to take a moment about E in order to get CB or a moment about C in order to get EF. On my paper, when I was practicing this morning, I took the moment about C, so I'm going to stay with that. So moment about C. So if I'm taking a moment about C, CF and CB are not players. EF is a player, and it is a 1.5 meters perpendicular distance away from point C. And the 4 kilonewton external force is a player, and it is 2 meters away from point C. Grabbing the direction, if I'm rotating about C and EF is pulling down, that's a counterclockwise rotation, which is positive. And if I'm rotating about C and I'm pushing the 4 kilonewton external force is pushing to the right, that causes a counterclockwise rotation. Counterclockwise is negative. Let's see, so that gives us EF times 1.5 meter minus 8 kilonewton meters. Therefore, EF is equal to 8 kilonewton meters divided by 1.5 meters. And I get a value of EF equal to 5.33 kilonewtons. I recognize that you get a repeating decimal here. I'm just going to truncate at the 100 spot. So 5.33 kilonewtons. It came out to be a positive number, which indicates that I have the correct direction. So 5.33 kilonewtons in tension. And I'll write that so we have it. That now allows us to go ahead and grab the summation of forces in the y direction. So I've got EF, which is in downward, negative 5.3 kilonewtons, minus CB, which I had indicated as downward. I'm seeing this is going to be a problem. Not really a problem, but so we get CB is equal to negative 5.33 kilonewtons. The negative, again, doesn't indicate that I have that the force is negative. The negative indicates that I had the wrong direction, as has been our practice. I'll put the right direction right over here. And then go down and fill in my answer. And we said 5.33 kilonewtons. The correct direction has the arrow going into the pin, which would be a reaction to the member being in compression. Well, that's pretty quick. All right. I'm going to go ahead and stop this video so we can get it posted onto our YouTube channel. And I think I have time to do another one this morning. See you in a little bit.